Okay, we have finished the interpolation section of the channel. Now we need to add some water to the channel so that we can test it. So we call that a channel boundary condition, and we are going to be adding an inlet. So we'll start by zooming into the upstream section of our channel, and then we need to turn off some layers so we can see where we want to put the channel. Collapse the widget and open the boundary condition editor. Add a boundary point and select the point where we want to load the inflow node. Save the widget, and then we fill out the widget with the data that we want. And this is the time series data. So it's time. This is a time inflow hydrograph with time in hours on the left and discharge in cubic feet per second on the right. So Flow2D uses either hours or days for inflow hydrographs. We are using hours in this case, and we use CFS or CMS depending on your units. So it'll always be hours, and then CFS or CMS depending on your units. And then of course if your hydrograph is in days, you would check this checkbox, and then this column would be days. Okay, so that's how that works. And then you'll see it looks like this, and then we'll schematize that structure. So let's go ahead and try that. Alright, so we want to collapse the widget and open the boundary condition editor. And then we'll zoom in on the upstream side of the channel. And I'm going to change from Google Hybrid or Google Image to elevation so that we can have a better idea of what we're looking at. Then I want to turn the channels off so that we're only looking at the schema data, because we want to make sure we assign to the schema layers, not the user layers. Then we'll use a point right here, add BC point, click that, come over to the map, and you want to just select the first grid element, or excuse me, the first left bank element of the channel. This will assign an inflow node to the whole channel cross section, but it always defaults to the left bank because that's how we connect the cross section to the channel. Then back over here we'll click save, and this will just say that you added a boundary condition, and don't forget to use the schematize tool to commit them to the data. Click OK, and let's start with our naming. So we'll call this Cocoa In because that's the Cocohatchee channel. And then this is an inflow hydrograph, and we are defining it for a channel, not a floodplain. And it's a time series, 24 hours. I've already done this once, so you can see that it's already there. But if you needed to do your own, or you needed to do a different one, you could do that. So let me show you that process. So normally this would come in with a time series called time series 1. But I'm going to do this. So time series 2, we'll rename that. And let's just call this 100 year, 24 hour. Now in South Florida, your 100-year hydrographs are typically 72 hours, not 24 hours. This one is truncated so that the class moves along a little faster. You could even do it like for 10 hours, just speed the class up, and you'll see what I mean. So 24 hour, you'll see what I mean by it's not the full hydrograph. Click OK, and then when you open that hydrograph file, that is back in here, project data. This one is channels, maybe not. Oh, I know it's not channels. This one is boundary conditions. And this one is a 24-hour, 100-year inflow. And again, Control A, C, W. Now I'm going to tell you again. And then we put that right here and click paste. There we go. And so you can see like it's still all the way up at 1,000 cubic feet per second. So that's how we know that this hydrograph isn't long enough. It should go back down to like the base flow for this channel. And the base flow for this channel is probably not 1,000 CFS. All right, so this would, in a real project, this would extend out to 72, possibly even out to 90 hours, depending on, the drainage time of your channel, of your system. Okay, so that is ready and finished. So now all we have to do is click the schematize, and we're just going to overwrite the data that's in the system. Click yes. And what you'll see is that you have one inflow node, and we already did this in the boundary lesson, like 32 outflow nodes. Now, and I may have discussed this in the boundary video, but these ones on the outside set the tidal stage, and these ones on the inside allow the water to flow off to like excess, excuse me, water that is in excess of the tide will leave the system at like a normal depth discharge relationship. And you see we don't have a downstream boundary for our channel because we are terminating our channel on the floodplain. So that means that this will just share with these cells down in here and fill this area at the tide. Okay. All right, let's go ahead and let's see what the instructions say. I think that's it for this video. It was channel boundary conditions, and we discussed the inlet and outlet nodes, so let's go ahead and stop the video.